Or,
You can just do substitution.
well, it isn't even that. Yeah, you're right. You're right. That I didn't even see that. I was going to call him a jerk for another reason. I was all ready to do a trig substitution. I was going to factor out 7, which does not come out of the radical nicely. But Monty, fortunately, has a brain in his head where I don't. And he said, "Oh, stupid Newberry, that's a Calc 1 integral. You could have gotten that on a Calc 1 class." Did you hear him? He said that, stupid Newberry. Did you hear him? Under his breath. So he's right. Newberry's stupid. We all are. Nice substitution, right? 1/2 dt is x dx. So author fooled me, but not him. Rad t. So that's 1/2, and let's go ahead and write that as t to the minus 1/2. Right, this is the substitution. So what is the integral of that? 1/2 rad t plus an arbitrary constant. So 1/2 square root x squared minus 7 plus an arbitrary constant. Now, if you go and do the trig substitution, it'll work. It's just going to take an extra page of writing. So, thank you for saving me from that.
We do the trig substitution?
No, we're going to do it on so many others that we'll get all the practice we need there. If we don't get that practice, I will come back and do that. But let's see if there's others that, like the very next one's going to work out that ability, isn't it? Square root 1 plus x squared over x dx. Well, that's definitely not a Calc 1 integral. So 1 plus something squared is a tan substitution. 1 plus tan squared is what we're going to be modeling this after, right? We know that that's equal to secant squared. So if I replace x with tangent, and I have 1 plus tan squared, square root of secant squared, we get a secant there. So that's my substitution. Let's let x equal tan theta. Then dx is secant squared theta d theta. This is number 19. So integral square root 1 plus tan squared theta dx is secant squared theta d theta. The dx is always in the numerator, isn't it? Whether they write it that way or not. Is that a question? Or?
No.
Okay. And then x in the denominator is a tan theta. So, goodness, that's another secant, isn't it? So secant cubed over tan theta. This doesn't look like one of the sorts of situations that their little table telling you how to proceed is going to cover. It's not going to encompass this particular thing. I think this is more like the first one we did. Right now we're not seeing, I mean, if that were secant squared on top, it'd be cool. I'd say u equal tan theta, du d secant squared theta d theta.
The number 17, dt is 2x dx.
Yes. I agree.
And at the end, we're just going to have that x squared minus 7 plus 2.
Really? How come?
Because it's 1 over 2 times 2.
Oh, no, I think I'm right here, aren't I? Oh, yeah. You're right. Show off. Gosh, getting tired of you guys. You know, maybe I ought to start putting drugs in this coffee. I don't know. The ice just isn't cutting it. Anybody have a good recommendation for a morning drug besides caffeine? Something that won't get me arrested? What was that? Chocolate! That's really one of the better answers that you could have thought of. That perks you up, get a few calories in your system. I just did this when I shouldn't be erasing it. Oh well, too late now.
Yeah, too late now.
What are we up to? 21. 21, 21. Well, that looks like another trig substitution. What is that? 0 to 0.6? I already forgot what it was. 9x squared minus 25?
9 minus 25.
I know dyslexia rears its ugly head. And what's in the numerator? Just an x squared?
Yep.
So we'd like that 9 to be a 1. Let's make it a 1. How do I force that 9?
Factor it out.
Factor out a 9. Under the radical, right? We're going to factor out a 9 under the radical, so now it's 1 minus 25x squared over 9. And of course, the 9 comes out as a 1/3, right? 3 in the denominator, 0 to 0.6, x squared dx. And maybe we will rewrite that 25x squared over 9 as 5x over 3. Quantity squared. So the substitution,
X equals 9.
sine theta equal 5x over 3. Then I get 1 minus sine squared, which is cosine squared, and under the square root it becomes cosine. So let's see, I think maybe I'll write that as 3/5 sine theta for the derivative. So dx is equal to 3/5 cosine theta d theta. Is everybody okay with that? Almost always we're going to have to draw the little triangle for that. So a lot of times I just go ahead and do it, but it's not a 100% of the time that you end up doing that. So I guess I'll wait. Integral, or 1/3 integral. So when x is 0,
0.
theta is 0. 0.6, huh? So if x is 0.6, 5x over 3 is 5 times 0.6 over 3. That's 1, I think, isn't it? Is that correct?
Yeah.
So when this quantity is a 1, pi over 2. So I don't mind giving you those kinds of limits. X squared, I guess that's 9/25 sine squared. Dx is another 3/5. And then we have a cosine theta d theta. And underneath all this junk is a square root of 1 minus sine squared theta. Make sure I didn't miss anything. I've been making so many mistakes, I'll let you catch it now. I didn't make one here? Are you sure? Okay. Am I boring? Gonna put you to sleep, Monty? So the 3 cancels 5 times. That's 125?
Yeah.
9 over 125, integral 0 to pi over 2. So this cosine cancels this cosine. We just have sine squared here, don't we?
Yep.
Sounds very pleased, doesn't it? 9/25, integrals 0 to pi over 2, 1 minus cosine 2 theta over 2 d theta.
125.
Pardon me? Oh, I didn't even say the 125, did I? So 9/125, a nice round even number. Looks like an A. 9/125. Oh, I guess I gotta make that 250, huh? Multiplied by 2. The integral of 1 is theta. The integral of minus cosine 2 theta is minus 1/2 sine 2 theta, I think. All evaluated 0 to pi over 2. So again, when we plug in 0, both of those go to 0. So just 9 over 250. When I plug in pi over 2, I get pi over 2 minus, well, that's going to be a pi over 4, isn't it? So I get 1/2 times rad 2 over 2. I think that's a rad 2 over 4. And I would just stop there, and so if I made a mistake. What? What?
If you put pi over.
See, I knew I was going to make a mistake. Look at that. Yeah, 2 times that is pi. Sine of pi is 0 again, isn't it? So 9 pi over 500, right? Is that right? Oh, well, somebody's saying yes.